Hi everyone, this is Mrs. Poland. This is lesson 6.10, where we're going over the four-step process for one proportion z-test. Let's read example 1 together. A study suggested that about 45% of Americans believe that gun ownership should be tightly controlled. After a shooting incident, 500 people are polled about gun ownership. 245 of them said that gun ownership should be tightly controlled. Do the data suggest an increase in the percent of people who believe that gun ownership should be tightly controlled? This is categorical data because either people are going to respond yes, they believe it should be tightly controlled, or no. So we're going to perform a one proportion z-test. So the first step, we state the parameter, the hypotheses, and the significance level. This is very, very similar to the confidence interval procedure. So the parameter, which we represent by rho, notice there's no hat, is the true proportion of people who believe that gun ownership should be tightly controlled. Notice that it is in present tense, and it's really just a restatement of the information provided in the problem. So now we're going to define our null and alternative hypotheses. So our null, again, you're only going to have everything stated in terms of the population parameter. So in this case, prior studies suggested there was a 45% support of gun ownership. But if you read closely, that last line of the problem, or the question itself, says, do the data suggest an increase? This means that the alternative is showing a greater than symbol, so that rho is greater than 0.45. And in this problem, they don't give the significance level, so you can choose anything. Typically, we would choose 5%. In this section, I would also include the statistic. So we know that from the study, 245 out of 500 supported gun ownership controls, and that turns out to be 0.49. Okay, so we're now going on to step 2. And in this step, we verify the 3 conditions. And these conditions are similar to what we saw in the confidence interval procedure. So the first is that it's a random sample. And initially it said as stated, but I think it's assumed because I don't see them directly stating it in the problem. The next is, it is reasonable to assume that there are more than 5,000 people in the U.S., and that should be a capital S. The necessity of that first condition is it allows you to generalize the results of your study. And the reason for that second condition, it allows you to sample without replacement. Okay, so now we're on to the third condition, is the large count condition. Notice that you're using P, not P hat. Why are we using P? If you look back into our null hypothesis, we're assuming P to be 0.45. Therefore, it must be used in that condition and in our actual calculations of our test statistic. The purpose of that third condition is it allows us to apply a normal model to the sampling distribution. Once we've completed all those steps, you do have to actually name that test. So we're going to have a summary statement. Since conditions have been met, we can perform, and the name of the test is a 1 proportion z-test. We're now up to the calculation step. You're going to calculate the test statistic, and the p-value. So the formula for the general test statistic is provided to you in your reference sheet, and it's the statistic, which in this case is p hat. You're going to fill in the parameter, in which this case it's rho, and then you're going to fill in the standard error. Now the standard error, you're going to use p and not p hat, so it's going to be pq over n, and then we're going to substitute in. So in this case, p hat is 0.49, our parameter is assumed to be 0.45, and then we're going to type in the standard deviation, the square root of 0.45, times 1 minus 0.45, which is 0.55, and n is the sample size, which is in this case 500. And we're going to enter that into the calculator. And your test statistic turns out to be 1.798. Now this formula should look familiar to you. This is actually your z-score formula from chapter 2. Remember, z is equal to x, which is the raw data value. In this case, it's our statistic, minus the mean, which in this case is our parameter rho, and then the standard deviation, which in our case is square root of pq over n. We now need to calculate the p-value, and it's really helpful to draw a diagram so we can actually see. So p, our mean, is 0.45, and again that represents p. We came out with our test statistic, which is 0.49, and since it's greater than, we're shading to the right. So the p-value is actually the probability that we're going to get this test statistic, p hat, greater than, as great or greater than 0.49. And what is the chance of that occurring, assuming that our null hypothesis is 0.45? So what you did with that test statistic is you converted it into this z-score. So the probability of p hat greater than 0.49 is equivalent to the probability of z being greater than 1.798. And we already confirmed in condition 3 that we can apply a normal model to it. So we're going to do a normal model. The low is that z statistic of 1.798. All the way to the right, 99999. And again, since it's a z statistic, a z-score, our mean is 0 and our standard deviation is 1. And we're going to enter that into our calculator. And I got a value of 0.036. Your value may be slightly different depending how you rounded, but I would always recommend having your z-score at least 3 to 4 places to get a better value or more commonly used value. Okay, and now we're up to the last step where we're going to interpret our p-value and state our conclusion. So for the p-value, we would interpret it as follows, assuming HA of the null hypothesis is true, in other words, p is equal to 0.45, there is a 0.036 0.036 probability of getting a sample proportion of 0.49 or higher purely by chance. We then say, since our p-value is less than 0.05, we reject HO. Again, our p-value of 0.036 is less than 0.05, so we're going to reject HO. And that gives us convincing evidence that there's an increase. We reject HO in favor of HA, so we have evidence that there's an increase in the proportion of people who support gun controls of gun ownership.